Let's begin with the problems. The first problem is that since my graduate studies, I never accepted the quantum chemical notion of valence. Never. Why so? Because I am a scientist. Scientist means quantitative studies, namely mathematical treatment of a problem producing an equation that can be verified with experiment. This is a quantitative science. The notion of valence in quantum chemistry is a nomenclature. Why so? Because it does not produce the equation of attraction among the atoms. That equation, not only that equation has to show a positive force. Look at the valence. This doesn't exist even in the wildest dream. This is what they do. They kind of nomenclature to indicate bonds. You see the wave function. This is as a first step in this very complex structure of nature. This should be respected, provided, because we don't jump immediately and discover everything. No, what I have to say is perhaps a tiny little step ahead. But the point is, once it's presented as the final situation in the structure, now that is politics. I'm sorry, I do not accept that. In any case, why I do not accept that? For the following reason. This is what I said to my graduate studies. This is, suppose this is the hydrogen atom, okay? Quantum mechanics describes the hydrogen atom with an accuracy which is unbelievable. That's why now it will remain for the history of science. The Balmer series, you can represent the Balmer series with no manipulation of number form factors. No, Balmer series to the 10th decimal after the period. Unbelievable accuracy, quantum mechanics. Now this is an hydrogen molecule. You put them together, and you have an historical an accuracy of 2%. And here's the beginning of the politics. 2% also is small. Dr. Santilli, 2% is small. That statement that is small is fake. 2% of the binding energy, Professor Ringazin, correct me, 2% of the binding energy of hydrogen is 954 kilocalories per mole. It's an enormous amount of energy. Now, so this indicates that quantum mechanics, in my opinion, perhaps this is the most important statement that I have in this lecture, that while quantum mechanics is exact for the condition of the originator, structure of the hydrogen atom, for the structural molecule, beginning from the simplest possible molecule, is not quantum mechanics is inaccurate. It's not the final theory. The hydrogen atom. When we go to complex molecule, the deviations are truly embarrassing. Anyhow. Now, this has been done by quantum chemistry. They have essentially multiplied the Coulomb potential by a function, by an arbitrary function, and this is called the so-called screening of the Coulomb law. And there have been all sorts of prizes on this. Of course, they reach an exact. They remove this 2% correction. They reach an exact numerical representation of the hydrogen, and then when you go to a higher, they have problems. But why I cannot possibly accept this? Again, to be a scientist, I must disclose, I must say when I believe it's politics, I have to say so. Otherwise I become an accomplice. You see, the quantum of energy only exists for the Coulomb potential as quantum of energy. When you multiply by a function, an arbitrary function, the screened Coulomb potential admits no quantized energy level at all. Therefore, the use of the name quantum chemistry for screened Coulomb potential is purely political, because they cannot say that they have they cannot admit the truth. Namely, that they exit from the class of equivalence of quantum mechanics by screening the Coulomb law. They cannot admit we are out of quantum mechanics. They lose their job, their chair, they've been thrown out, their wives have been called in the middle of the night. These things happen all the time. But the point is that, the point that persists, the map from the Coulomb to the screened Coulomb potential is a non-unitary map. So by very conception, the screened Coulomb potential is outside the class of unitary equivalence of quantum mechanics. Confirm what I told you, that when two hydrogen atoms, you are outside the exact validity of quantum mechanics. Quantum mechanics remain valid, yes, as an approximation. The moment it's claimed to be exact, then then it is Pauli. But there are many, many, many more. You lose the screen, the Coulomb potential, do you violate the Galilei symmetry? This implies the violation of the phenomenon in others in primitivity theory. After the screening of the Coulomb potential, since you have lost the basic symmetry, you cannot claim that there is even the Hilbert space. What's going on is unbelievable, unbelievable. But why? Because it's all nomenclature, 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 without quantitative, rigorous treatment. In any case, it's so elementary to introduce an arbitrary function that is fitted from the data, and then they claim that I represented exactly the binding energy of the hydrogen atom, and quantum mechanics is exact. Ladies and gentlemen, I feel very, very uneasy. In any case, now let me tell you additional reasons. I feel uneasy. If any of you can disprove this point, I will be grateful, because there are lots of things in the industry. We're talking about, we're entering now slowly into the foundation of a technology known as the Magnegas technology. What is going on behind the Magnegas technology? It's extreme complexity. We will try to enter progressively, because if we jump at it, then I will lose all of you. But this is a fundamental point. It is my contention that, and I think has been proved by one of my graduate students in a refereed paper, besides being an opinion, that the contemporary notion of valence necessarily implies that all substances are paramagnetic. All prediction consequences, all substances are paramagnetic. You can see it, you don't have to do calculation. Go back to the hydrogen atom. Look at the orbitals, the hydrogen atom. The orbitals of the hydrogen atom are like this. The hydrogen molecule, they are like this. Like this. They are in all the space. But then, since there is no clear definition of the valence, under a sufficiently strong external magnetic field, you will polarize. You will polarize. But the hydrogen molecule is diamagnetic. So already you see a direct violation. And the only thing that they silenced, this point is now known for 10 years. I fought with my colleagues at MIT like crazy. But they know it, but they don't mention, because they cannot claim they are outside quantum chemistry or quantum mechanics. This is the case for the hydrogen molecule. Another point in which we have the disagreement. The central contention of hadronic mechanics and chemistry is that in this bond there is a new force. There is a fundamentally new force, which we'll review, which is non-linear, non-local, non-Hamiltonian. They claim, no, the moment they admit non-Hamiltonian, my God, this means exiting from quantum mechanics and chemistry, forget about it. They will cut their thumbs, they will chop their fingers, because otherwise they will lose their job. So they cannot admit the X, that's why they multiply by an arbitrary function. No, it's still the Coulomb potential, just with the correction function in front, but there's no force, it's still Coulomb. Scientific reality must be admitted, even though there's sometimes harsh. My dear friend Raul from Mexico has been my friend for many years. I felt bad when I told you the reality, but I could not do otherwise. So I apologize and beg for your leniency. This is the case. Do consider the hydrogen molecule. There is by using all the interaction that you want in the 20th century, quantum mechanical, which means Hamiltonian, there is no resulting force. If you can prove that with quantum mechanics you can produce a force, I would recommend you to the Nobel Prize. I will go in person with a banner, the foundation recommending you for the Nobel Prize, because this will be a major discovery with enormous implication. This is the very, very essence of what we are saying. Again, there is a reason why the symbol is here. The very birth was the symbol of the Institute of Basic Research from day one when it was founded in '81. Because, sure, valence electrons, Dr. Ruggero from MIT, Harvard, Ruggero, everybody knows that the electron has a point charge. So how can you think this new force? This is a point charge. So when valence electron pair, they remain point charge. It's just you change the Coulomb law. I disagree with my point, which they know well, but they intentionally ignore, is that there exists no point-like wave packet in nature. There is no point-like, there exists no point-like wave packet in nature. As a matter of fact, the wave packet of one electron is as big as it becomes 0 at infinity. One electron is in contact with the rest of the universe, the complexity of our world, compared to the politics in academia. So once you admit, even at the Compton radius level, you immediately see the wave packet create a volume of contact, a volume. Volume means the entire mathematics of the 20th century collapses because it's local differential, topology, everything, symplectic geometry, everything collapses because you cannot reduce this volume to a finite number of isolated points. They do it in MIT, Harvard, Berkeley, oh yeah, but not in the reality. Not in the reality. Secondly, this is contact. Means that if you try to represent this area with a potential, don't do it. Don't do it, because I did it for years. And then I had to trash everything. I didn't publish nothing, thanks God. But, because this is contact. When you have a contact, think about a balloon moving in air. It's that motion. You cannot represent that motion with a potential. There is resisting forces. By concept, you don't have a potential. You don't have, technically, they are variationally non-self-adjoint. You cannot represent with the Hamiltonian. And that's what the birth of hadronic mechanics. Okay, this is a couple of publications that you can look at. And now, what is the essence? How do we construct hadronic mechanics, hadronic chemistry? By having the regular Professor Ingrasin, this is the regular isotopic formulation of hadronic chemistry, which we call also, Professor Schiller and I, we call it isochemistry. And you do it where you pick up a non-unitary transform, and you map everything you can, you have to transform. The unit, the product, Schrödinger equations. But again, I have to bring to your attention already from here. See, you have the nonlinear effect. They are sandwiched in the product in between the Hamiltonian and the ket. So this it simplifies the nonlinear solution immensely. But look at, I have to bring to your attention again this. This is a canonical. See, the calculation in quantum chemistry now requires day and days, even with the biggest computers. Why so? Because the power series, they're very weakly, at best they're weakly divergent. Often they are divergent. Look at this canonical expansion. When assume that the parameter W is bigger than 1, this is divergent. Well, the moment you use this hadronic chemistry, isochemistry, instantly it becomes strongly, you turn it into strong convergence. So the calculations that we did with Professor Schiller, we published in the paper that we reduce the computer calculation by a factor of 1,000. It's not true, it's false. We debated with Don a long time. We had to reduce it by a factor of 50,000, 70,000. Then we decided to put 1,000 because otherwise people would not have, the paper would not have been accepted, the people would not have believed. It's obvious from here. If the ISO unit is very large as it is, the isotopic element is very, very small. So here you have the convention that you want, very, very fast. So, okay, here is the very birth of hadronic chemistry, which I call the Animalo-Santilli effect. I have to go back in time. That is why Professor Animalou is one of the founders of hadronic mechanics and chemistry. And he has developed his own theory on regarding the Cooper pair and so on. Let me go back in time. In 1978, in the original proposal of hadronic mechanics, I worked out from A to Z the solution of the synthesis of the pi zero from an electron and a positron. Now, electron, it turns out to do this, you needed a very, very strong attractive force. Coulomb attraction was not enough because there was 134 MeV missing energy, much more than the neutron. 134 was missing, and you could not use relative energy. So you had to use a non-unitary, very, very high non-unitary transform. And but what Professor Animalou discovers subsequently is the following. That was his discovery. Then we worked together and we published this paper in, I don't remember several we published together. Yes, you can read it there. It's available in free PDF download. He discovered that attractive force produced by the non-non interaction is so strong that it works also for particles with the same charge. And he applied this discovery, he applied to the Cooper pair. And he developed his own Animalo's superconductivity, which is beautiful in my view. But then we went back together, and then together we say, okay, but this applies to the notion of valence. When we have two identical electrons, then we can extract what was missing, namely the attractive force between two identical electrons, coupled at a short distance, and that force has got to be positive, has got to be attractive. But the mechanism is not that simple. We have to work a long time. Remember Professor Nimalou. Why so? Because hadronic mechanics and chemistry only apply for the valence coupling. You see, quantum mechanics applies here. And this requires a non-unitary transform. When you go to the structure of the hydrogen molecule, situation is different because you have conventional Coulomb interaction from the nuclei. You cannot use you can use non-unitary transform to represent those interactions. It will be a minestrone. A fundamental point to understand hadronic mechanics and chemistry, that by conception, construction, axiomatic realization, experimental verification, all the effects that we study are identically, they rapidly goes to 1 to the unit anytime mutual distances are bigger than 1 Fermi. So here, in this situation here, we do have 1 Fermi, non-unitary hadronic mechanics, the covering, yes. But when we go to the structure of the hydrogen atom, no. Hydrogen molecule, no, because we have the charges from the nuclei to the electron valence pair have to be conventional. And finally, when we understand this point, and we publish this paper, which I believe is at the foundation of hadronic chemistry, in my view, and this is basically the mechanism. You see here, this term is isotopically lifted, but the Coulomb interaction is introduced as it should be, purely quantum mechanics. You do that, and do simple calculation, and you end up here. This is an interaction between the valence electron so strong becomes a Hulton potential is one of the strongest interactions, and Hulton potential again collapses very rapidly to the Coulomb at 1 difference. Everything else, once you know this mechanism, but you have to review it with calculation and study, then you understand the hadronic chemistry. What is the consequence? The consequence is that now you have what is called the strong Santilli-Schillerdi valence bond. You have now, since now the nomenclature is gone, the idea, the concept, the politics is all gone, you now have an equation that sets you a very strong attractive force between identical valence electron in singlet coupling with the spin up and down. Once you have that strong force, it's very difficult to break it down. And we believe that this represents the strength of, at least gives a step ahead toward the future representation of the strength of the valence bond. Look at the strength. Look at my finger. I cannot break my finger. And this means, thanks God, it's strong. But it has consequences. Professor Enriquez, we discussed this your beautiful thesis in Mexico. Precisely these points, we will elaborate better after your beautiful presentation that he has made a major contribution in hadronic chemistry. That's why we are very grateful he's here with us. What is the consequence? The consequence is the orbit. What is the orbit of the pair? You have now a valence pair coupled very, very strongly. What is the valence? What is the, well, the orbit then basically becomes something like this, kind of an O-shaped situation. And this is at zero temperature, the hydrogen molecule is flat, and the valence electrons are like this. Of course, with Don-Schillerdi, we computed the percentage of this stability. It's not a permanently stable bond. No, of course not. Otherwise, the electric current will be made by valence electron pairs. Double the charge and neutral magnetic moment will be a fantastic electric current. No, this is not possible because the bond has its own life. But it turned out that it's more than 50%. The calculation were about 70 to 80% lifetime in this state. So the conclusion, this appears subject to, we are told, entering now terra incognita. It appears that this indeed is at least the dominant structure of the hydrogen atom at absolute 0-degree temperature in more than 50% of the time evolution. And then with Don, we apply to to the water molecule. I have one remark to bring to your attention. We are entering now slowly, progressively into you see, this is at the foundation of Magne hydrogen. We will see it in a moment. And this is at the foundation of Magne gas, the Magne gas technology. What is this? This is a conventional water molecule, nothing more. But I want to bring to your attention a very important point. Namely, in the nature, if you look at normally an hydrogen atom has an absolutely spherical distribution. It's a sphere. It's a perfect sphere. That's why there is no infrared signature. And the same for now. But when it couples to the oxygen, then nature has set the orbitals of the hydrogen atom in a toroid, which is perpendicular to the symmetry plane of the molecule. In other words, the orbitals can do something like that. They couple with the oxygen, they go back. They couple with the oxygen. They don't go around like this. No, they don't go like this. No, they have a very intricate connection in a plane that is still unknown, ladies and gentlemen, quantitatively still unknown. Now, this immediately will tell you that there is a new force that can be used. Now, the total overall magnetic moment of the water molecule is very, very small. Water is paramagnetic, diamagnetic, as you know. However, if you got an individual atom, then you can see this magnetic moment. So we interpret the liquid state as being, there is another water molecule bonded here by using north-south, north-south. So imagine this as inverted. We will discuss this in a moment. Let's enter now in the first and most important consequence of hadronic chemistry. The consequence is the prediction of a completely new chemical species. That is still very debated. So from now on, ladies and gentlemen, presenting my view, I hope that some of you can help us to finalize experimentally the situation. Those are the original publication up there, 1998, and there were several publications. The first scientist to answer the call was Professor Asghar Aringazin, who immediately calculated the value of the magnetic fields of this toroid, and it turned out to be, if I remember correctly, 1,450 times stronger than the magnetic field of the nucleus of the hydrogen, which is the proton. So you have a very strong magnetic field, and you can couple north-south, north-south. This species was theoretically predicted when I was at Harvard with DOE support, because my job was to look for new fuel, new clean fuel. Department of Energy, they wanted me to produce new. So I was looking for a new species that will be ecologically better than gasoline. And to do so, I accepted the grant. That was incidentally was under invitation. It is true, documented. I said, yes, I'll do, but I cannot work with a valence bond, because the valence bond is so strong that we end up with the usual debris in the exhaust. I need the freedom to study a new way of bonding atom, which by conception has to be weaker than, we're talking about in the early 80s, weaker than the valence bond. So as when we do combustion, the bond can break and we can reach full combustion. All this now has been realized at the industrial level, let alone the scientific level. And so the way to do it was to use the bond molecule atoms via their magnetic fields. That's the name magnecule. In reality, it's extremely complex, ladies and gentlemen. Here in this bond, not only you have this magnetic field, but you also have the electric and magnetic fields of the nuclei and the electrons. So the bond is very, very complex. However, what has been proven, and Professor Aringazin and his associates confirmed, that the overall bond is indeed positive. The overall force is positive. Among all those electromagnetic forces operating in this configuration, the bond is positive. But what is the most important point here from an ecological viewpoint? This is Magne gas technology. We are a clean burning fuel. What is important here is that this bond is not as strong as the one, it is weak by intention. It is stable at ordinary temperature. You see, it's created by an electric arc. The moment you remove the electric arc, the electric arc creates this bond. The moment you remove we're talking about incidentally, at the atomic distance from the arc, we normally realize 10 to the 12, 10 to the 14 Gauss of magnetic field. millions of times stronger than the Tallahassee magnetic field at atomic distance. Once you remove this for a 300 or 400 kilowatt magna gas reactor, once you remove that electric field, the electric field creates the pair. The moment you remove that powerful magnetic field, instantly this turns into a spherical distribution. But is the couple, toroids that enter into an orbital, the spherical distribution. The removal of the source of the bond does not break the bond. Only combustion breaks the bond. So at the time, the only way to separate those atoms is at the time of combustion. Let me different way. Every magnetic effect has a Curie temperature. In this case, the Curie temperature of this bond is the combustion temperature. But the bond is very weak, and so the loss, the energy that we lose to break the bond is very, very small. And that's why you have to go into magnagas.com website. This is a public company listed on NASDAQ, and everything is certified many, many times. We achieve full combustion. There are no debris, none whatsoever, no hydrocarbon, no diamond, nothing. It's the gas that achieves total combustion, and therefore has a very high efficiency. But the principle is in here. Now, let's go back to the 90s. How do I prove the existence of this? It was an enormous struggle, ladies and gentlemen. Years and years, and I was looking, because I want the best laboratory, chemical laboratory in America, the best machines, both in the corporate world as well as the academic world. And what you see, well, they will show me, give me analysis of magna gas. I will show you a peak, beautiful peaks. And they look at me very suspiciously. They said, Dr. Santilli, but this is ultra Kins formaldehyd contanquintyl with this the polarization. I said, but are you sure about this? Because they had one measurement on the GCMS, and they had one result for one peak, and with that result, they claim a scientific conclusion. I never accepted that. To be scientific, any detection has to be at least double. Forensic laboratory in America, and I think the rest of the world, by law, before making a claim, this substance is such and such chemical compound, they need an independent verification. Otherwise, they can send somebody the electric chair. In academia, in the commercial, this does not exist. So it was years and years of denial. No, this is I remember a big laboratory in New York said, no, this is I know there are a little polarization to be studied, but this is a molecule. Molecule means it is a valence bond. You see, I was looking to establish experimentally the existence of cluster bond was not entirely valence. At least a component had to be new, the magnetic type. And so it was an enormous struggle. Finally, the military, I became an American citizen because of research with the Air Force. The military helped me. There was a McClellan Air Force Base in Sacramento, California, in 1998. I discovered that they had a GCMS, a gas chromatographic mass spectrometer, equipped with infrared detector. Maybe Carla remembers, once I discovered it, they said that they would like to do the test. Maybe you remember. He said, I got to go. She asked me, where are you going with all this rush? I got to go. And I took the first plane, and I went to this laboratory. They were very, very positive. And this is what came out. I believe the result of that test that established, to our understanding, experimentally, the existence of a non-valence bond. Remember the key point. Don't get diffused by tangential aspect. Where the main scientific issue is that the bond to be new has to be non-valence. Magnecule, you don't like magnecule. Call it potato-cule. Call it anything you want. It's irrelevant. The point is that the bond is not a valence. This is the key point. And why this instrument was the only instrument available all over America in 1998 that helped me. Because, see, this is what happened at this magna gas from 40 to 400 atomic mass. We cut the spectrum at 40 because the major component was expected as CO. So we want to cut it out. And major components are hydrogen and CO. So there is, at this level, there is CO2, a little CO2 at 44. So this is what you see, this is what appear, all those clusters. Now, and here now, here is why the analysts were cooperative. They were cooperative because normally what chemists hear this, immediately what they do, cuts them, put the bar here, and look at the component of this cluster. They look at the component, and they're all conventional. But this, ladies and gentlemen, is scientific, is non-scientific nonsense. Non-scientific nonsense. Why so? Because when you see a peak, and you look, you have to study this peak at this atomic mass value. This is the atomic mass value of this peak. If you decompose it into the constituents, you jump, then you look at this. The components are H2, CO, and other things. But sure, but those are, you can claim that those are the constituents of the peak, of that cluster. You cannot claim that that cluster consists of those. No, because they are bonded. They are bonded together. So these are concepts that has been impossible to penetrate in academia, in chemistry, because chemistry perhaps the biggest obscurantism mystery is precisely in chemistry, in my view, nowadays. No, we have this cluster. I want to see what this cluster is. I already know the continuum, H2, but H2 is all the way up here, and HCO is here. I want to study here. And so what they did, they analyzed each and every cluster in their bank. This was talking about the military. At that time, they had 500,000 molecules in their computer, and they tried a match. And none of that, they had to admitted in writing, the military are outside mumbo jumbo, this very, very unfortunate politics in academia that's so damaging to mankind and to themselves. So they admitted in writing that none of those peaks could be identified with an existing molecule. None of them could be identified with an existing molecule. At that moment, we were only halfway through. Why? Because the moment you make this statement to academia, famous professor at MIT, Harvard, Berkeley, and the Université de Paris, and of course the Imperial College, oh, Dr. Santilli, man, oh, give it to me. Immediately, half an hour, I locate a molecule that fits the data. What kills all this fat? This is academic fat. Really, sorry to use heavy language. What kills was the machine killed this fat. Why? Because the machine was a GC-MS/IRD, namely had an infrared detector attached to the MS. Then the situation is more serious. Why so? And it's a single machine. When you do the injection in the machine, without changing nothing, because you measure the MS, you measure the spectrum, and jointly, without changing nothing, no mumbo jumbo, changing nothing. You just push the button, you switch to the study of the infrared. It's a machine used by a forensic laboratory that they risk to send people to jail, not in American academia or no. So and also for serious military have, because the military are serious. So the GCMS. So the analysts switch this without changing the spectrum. No, the spectrum remains frozen from 40 to 400 atomic mass units. Switch to the IRD. And what appeared? This appeared. At that moment, there was a big commotion in the laboratory. They called everybody. The big brass came with all sorts of... and looking at the machine, he was saying, no, this is impossible. This is absolutely impossible. He freaked out. He remembered that one of us was moving around the machine like this. He was trying to think what's up. And I told them, I don't remember his name, but it's in the books, his name and letter that he put his name and signed. I don't remember his name now, it's 22 years. He said, no, but this was predicted. This behavior was predicted. And he looked at me, absolutely, it's not possible. You're dreaming. It was so called the other chemist, and then it was, and so we spent another, I don't know, a day and a half doing and repeating this thing. Because here is the point. See, novelty cannot exist. Novelty does not exist. Novelty cannot exist. And if novelty shows, has to be some, the instrument is not adapted. The column, no, the column, the temperature of the column. Oh, the filament in between the column of the GC and it may be wrong. Oh, no. All this possibility were considered to prove that it is not true, that this can is. Why? Why all this commotion? Why all this commotion? Here, Professor Ringazin, who is one of the best experts in the field, that's why he's one of the founders with the widest knowledge in mathematics, physics, and chemistry, can tell you much more than me. He's the expert. I should not even mention the point, but let me mention. When the molecule has no infrared signature, it needs perfect sphericity. The helium has no infrared, the hydrogen. It's very difficult to detect hydrogen. Those are molecules that are perfectly spherical. The moment you go to high masses, when you reach 40 atomic mass units, and you go all the way to 400, it is physically impossible that if those clusters have a valence bond, they cannot have a spherical symmetry. Therefore, they should have appeared with all sorts of peaks. The reason why they freak out when they saw this, and there was this big commotion calling the general and everybody, and then there was repeated, because this was flat, was completely flat. Namely, all those peaks, none of those peaks had a valence bond. None of them. Because it had one valence bond, careful, one valence bond at its atomic mass unit, let's say 350. No valence bonds at 350. Because if you go to 2, the hydrogen has a valence bond. No, that's why you have to study the structure of the cluster without smashing it down. So they should have been large. Once they saw nothing, then this was freaked out. And that was the moment of thrill. I called Carla and I said, I don't believe what I've seen. I was at the hotel near the base in Sacramento, and I took the first plane back home, and I wrote this long memoir, about 100 pages, and presenting, after 20 years, presenting the hypothesis of a magnecule, namely, that by definition are ordinary molecule or ordinary dimer, molecule H2, CO, CO2, etc., ordinary dimer, OH, CH, etc., and this is very, very important for industrial application, individual atoms bonded with a bond which is primarily, but not entirely, of magnetic origin, caused by the control of the orbitals down to toroids to create this new force. It's now called the Santilli force or whatever. One last point. Notice that this was identified as the CO. It was wrong. The reason, because it was in reality is to be here, to be necessarily the CO2 is over 40. So this tells you how this enormous magnetic fields render the detection with ordinary machine very, very questionable. Let me move now. At this moment on, I want to show a few little things. If you don't believe it, at the end of my lecture, please, I beg you, and let me so. But study the literature if you want to have a quantitative comment and contribution. You've got to study the field. First of all, what do you see here? This is magna gas. What you see here, first of all, let me see. Ladies and gentlemen, this is H3O. H3O. Because it's a 19 atomic mass unit. And then you see what is the H3O? Of course, it's H2O with an atomic individual atom of hydrogen attached to the water molecule. This is COH, because it's 45. What is COH? CO triple bond with an individual atom of hydrogen attached to it. And then there is this CO2H. This is stable bonds. You feel them periodically, systematically. There's not, no. And then ASCAR, there is a peak at 79. We do not understand what it is, not even conventionally. We don't know what it is. So keep in mind that this is being published in a paper that finally I hope I have to finish. And the title is the apparent detection of H3O, CO3, and other anomalous molecular species. And now, here I want to show to your attention, this is very typical of the magna gas technology. We call accretion by an hydrogen atom. It is extremely anomalous. No chemist that I know in academia admits the reality of the scan. We do it systematically. I've been so fed up about this political, I call it a political skepticism by academia, because they throw the blah, 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 but the moment is, please, let's re-examine. Oh, no, they don't do that. And that's clearly, it's not scientific, I'm sorry. So this is extremely anomalous. Why? Because here you see, what you see here, 150, 151, 152, 153, 154. This goes on for hundreds and hundreds. This is only one of many, many of those. Namely, you see cluster that experience the accretion of one atomic mass unit, namely one hydrogen. What does this mean? This means that there is an anomalous addition. There is an anomalous addition of individual, that means, first of all, establishes that magna gas has individual atomic hydrogen bonded in those clusters, individual atomic hydrogen. And this, when you will see the documentary tonight, you'll see magna gas cutting in a flash. John Pace will present it to you. 6 inches, that's 25 centimeters. Very hard steel in a flash, cuts 25 centimeters in a flash. The temperature of magna gas is more than double the ordinary temperature of acetylene, of natural gas, all sorts of anomaly. Why? This is the reason. Because it has individual atomic hydrogen ready to perform the job. And let me keep going. This to give you an idea of the complexity of the magna gas technology. That's why when I'm asked what is the chemical structure of magna gas, I have to answer, and I do routinely, I do not know. Magna gas contains, those are various tests, but magna gas contains, those are magna gas essentially. The others, I think they were hydrogen. Well, you can see there. But the point is, look at this. Magna gas contains all chemical species from 2 atomic mass units detectable, but those are not the background. No, no, no. Those are, you see the count. You can see the count there. Those are, they contain detectable species with all atomic mass units from 2, which is the hydrogen, all the way. We have measured up to, this is 170. We have made, no, this is up to 75. No, we have measured to 150, up to 200 detectable in certain cases. Now, how do you interpret this with a valence bond, ladies and gentlemen? Then, there is a limit beyond which you can push an old theory of now belonging to the past century without losing the face, without losing your dignity. No. We need fundamental novelty to understand the structure. The only way I know quantitatively do prediction, calculation, and then check it with experiment, because I'm interested in experiments. This thing is that we are part of we work on the corporate, no academia. We are sued by the investors if we do mambo jumbo. In academia, you can do anything you want. Not in a corporate. Besides, we have the companies listed on NASDAQ. We have unbelievable control by the SEC. Everything is stated has to be verified, certified, audited. So the only way that I can try to quantitatively, and that's what we are doing now, Professor Ringazin will join us to initiate this quantitative study, is by using, of course, there are valence molecules there. Of course, there is H2. Of course, there is CO. Of course, but to initiate quantitatively that some molecules, conventional molecules, they are molecules. Here is what we call magna hydrogen. That now we have initiated industrial production. It's virtually unknown in academia, completely unknown in academia. I published a paper in 2003. But since the skepticism was so enormous, they do the measurement, for God's sake. My God. There were, remember with Carla, we used to go to the hydrogen meeting, international world meeting on hydrogen. We stopped going because I mean, the skepticism becomes, at a certain moment, becomes vulgar because they are not scientists. Because we offer try, we give the element free of charge. Try. No, no, the whole effort is to prevent the repetition of the measurement, because then otherwise it could be confirmed. So clearly this manipulation had become so fancy. Anyhow, this was done at the laboratory. It's in 99.8 pure hydrogen. This was done with GCMS at extremely high temperature, the highest admitted by the instrument, I think was 400 C, and other things to destroy the magnecule. And then separately, the specific weight was measured. And you can see here, the specific weight turned out to be, I think, 7 times the specific weight of ordinary hydrogen. I repeat, the specific weight, this was signed by the laboratory director, ladies and gentlemen. Don't think, no, you will change this, you modify that. Signed by laboratory director. Specific weight, 7 times ordinary hydrogen. And the purity was 99, of hydrogen 99.8. Unless you admit the existence of a new bond or non-valence, then it becomes surpassing all level of dignity, let alone the species that was this species I produced this species for academic reason to publish the paper, etc. Now what we are in the industrial, we're organizing right now industrial production. No, this is a case illustrates my word, obscurantism in chemistry, unbelievable obscurantism, because we are entering now in industrial production of this species. There is not one single word in academia. Zero. Absolutely zero. It does not exist. When you propose to redo that, no, because the moment they consider the experiment, they admit to their colleagues the possibility that quantum chemistry could be surpassed. And they will lose their job. They will have their hand chopped out, their wife being called in the middle of the night to exercise pressure to review. This happens routinely every day. That's why as an American citizen, I feel extremely sad about the suppression, systematic, organized suppression of scientific democracy, as well as serious conduct by scientists in America under a river of public money. In chemistry, they are using a river of public money that we have systematically proved to be non-scientific nonsense. This is the unbelievable situation. We try to approach some politicians to denounce this thing in America. I failed. My last hope was presidential candidate Ron Paul, that he had shown some independence from organized interest. I was hoping at least he will give me some credit, and will start at least a voice of doubt that this has got to be stopped. The future of America and mankind is here at stake. We need new technology. We got to move forward. Well, Ron Paul granted me a 25 minutes conversation by phone. It was very pleasant. And he said, you have to assume the leadership of political leadership for scientific renewal. Yes. The moment I send you a small report of the dirt that goes on in academia, it disappeared in a flash. So this was my last try. I said, there is no, this moment, unless fellow Americans, there are a few in this room, unless I stopped, because I had it, I will continue from now on, my last years, I have to produce science, unless fellow Americans take the lead and attack this organized obscurantism for money. I think our future is doomed, ladies and gentlemen, because sooner or later the economy will collapse, create then social upheaval. Social upheaval will create economic upheaval. Economic upheaval will be inevitable, create military upheaval. George Bush II, it is known, he had a committee considering the possibility of a suspension of the Constitution of the United States of America. It's a fact. Happened in my life, during my life, under my eyes. It can happen every day. And if it's happened in America, there will be a worldwide upheaval. It's up to us scientists to denounce corruption. Otherwise, either we are accomplices or we are servants. There's no compromise in this. There is no compromise. Anyhow, so we are now entering, this piece is now industrial, so it's not 7 times. But it is for about 3.8 times. The specific weight is about 3 times the hydrogen. It's good enough. What are the implications? Are enormous, because already at 3 times the specific weight of hydrogen has the same energy content of natural gas. Means you don't need to liquefy it anymore. No, because it's 300 BTU per cubic foot ordinary hydrogen, natural gas 1,000. You have 3.5, and so it is a revolution in the industry. But the biggest revolution is the reactivity of hydrogen that is much bigger than the ordinary one. Anyhow, here is another beauty I want to show it to you. This was, I assume I'll stop in a few minutes, Professor Corner. But I think there's some curiosity. They should know what's happening in the laboratory. This is a major laboratory. I removed the name. It's in New Jersey. It's one of the largest American laboratories. We sent them an element of our Magna hydrogen. That's why we don't even contact academia. This is one of the reasons why. Why do they do? Because they have the same machines. They have the same machine. Look what they claim, that our Magna hydrogen contains 20% of helium. Contain 20% of helium. This is a written, signed statement by a major American laboratory, analytic laboratory. If our gas had 20% helium, my God, would be worth a fortune. There is no helium, maybe parts per billion, parts per million, and not. This is what you get, because they have an anomalous reading, and they match it with the existing species. They don't say, no, this is a new one. No, never. They will cut their hands, change the measurement, adapt the temperature. To recover, they will do the impossible to recover, because novelty does not exist. And finally, this is what we call molecular combustion. It's a new principle of combustion. I want to stop. I think this is the last one. The name is a new form of combustion, because we basically, in ordinary combustion, most of the energy is lost in separating the molecule. This is with Professor Ringazin. We have H2 and O2 combustion in H2O. Nature has to break H2, break O2 to create H2O. And to break H2 and O2, there's lots of energy. What we measure, 57.5 kilocalories per mole, that is the residue. That is the residue of the amount of energy that you need to separate those molecules. If you don't include it, you violated the conservation of energy. But you read the best book in quantum chemistry, in chemistry, this point is not mentioned. No. They say, no, H2O, that's what they produce. However, if you have the same atoms bonded molecularly, and they are ready for combustion, then you end up with a multiple. You have MH and MO, you end up with a multiple of what normally you measure. This has never been, this is a theoretical prediction. If any of you can do it experimentally, I will appreciate. This is the testimonial by the City College of New York, the spectroscopic department, one of the best in America. Professor Hani and Nani was supposed to be here. We couldn't organize. They came to our lab with a swarm of equipment to measure the temperature of Magna gas. It turned out to be over 10,000 degrees Fahrenheit. Look at the chart. Double the temperature of natural gas, double the temperature of acetylene, the most powerful fuel. This tells you anomaly. Anomaly means you are in the 21st century. Every knowledge, a general rule, if you want to work with Magna gas, and any rule that applies for conventional molecular species is certainly false. For instance, they claim Magna gas has 23 or 27% CO. Can be, a high school student can prove that this is false. It is a belief, political belief. Why? CO is combustible and burns into CO2. So we measure the CO2 in the exhaust of Magna gas. The CO2 measure is 3 to 5%, sometimes 6% CO2. This means at best there can be 6 or 7% CO in Magna gas. Otherwise, we should have in the exhaust of Magna gas, which have 32, 35% CO2 in the exhaust. I would not even be mentioning the word Magna gas, because it would be, my God, a fuel that produces 35% CO2 in the exhaust. Forget about it. You kill the planet. And not me. I will not be associated. So every statement made by ordinary 20th century is 99.90% wrong. And finally, the biggest application of what I said today, including the Magna gas technology, the entire technology, I developed the entire technology for one purpose. The fuel is, of course, is important because it's ecologically clean. But it was developed for the new type of fusion without radiation that we will discuss tomorrow, developed thanks to our friends from China. Thank you for your...
Thanks.
Yes, I have my chest ready to receive bullets. No, wait, get the microphone. Professor Corda? I'm sorry? Let's wait for changing the battery, let's wait. Do you remember 1988? It was spring 1988. Yes, I abandoned you. I had to go to Sacramento. McClellan Air Force Base. Yeah. It was an unbelievable moment. Huh? 98, 23, Carl. 24, yes. 24 years, yeah. Passed very fast.
Okay.
No.
Solved it.
No, 14 years. 14 years.
Hello. Can I ask, how do you make one of these magnicules in the lab? So if I'm in my experimental chemistry lab, how do I make one of these magnicules?
Yes, we know how to make them.
How? Sorry.
Yes. Concretely, we will. You have to use an electric arc with very high power. If you use little power, you'll waste your time. High power means 100, 200, 300 kilowatts. An electric arc, 200 or 300 kilovolts. And you need power because then at atomic vicinity of the electric arc, within the liquid, it can be water, it can be ordinary water, distilled water, it makes no difference. At atomic distance between, well, first of all, the arc separates the liquid molecule most efficient in atoms. Number one, it's a smash. No molecule can resist a 300 kilowatt arc. Number one. Number two, the atoms are ionized, mostly ionized. And number three, you create a plasma, very, very beautiful plasma. You reach a temperature that is bigger than the temperature in the chromosphere of the sun, almost double. We measure almost double the chromosphere, the temperature of the chromosphere, not in the sun, around the sun. Once you reach those conditions, the magnetic fields at atomic distance in that plasma is astronomical, 10 to the 40, 10 to the 15 Gauss. Once you have those extremely powerful magnetic fields, it is known by quantum chemistry. Professor Ringazin wrote a magnificent memoir by recalling the Landau work and so on. There is a threshold of magnetic fields beyond which you will not polarize and control the orbitals. No. This, even in the Landau shift book is quoted very clearly. In one of their books is quoted very clear. But when you reach those astronomical magnetic fields, any belief that the hydrogen atom is spherical is cuckoo, is mambo jumbo. It cannot be. No, this squeeze in the toroid. And then you align them one next to the other. Let me see. Thank you for your question. It's a very important central question.
Professor Nimalou.
No, let me finish the answer to the...
Sorry.
Here you see the geometry. This is the geometry of those horrendous magnetic fields, and the atoms are squashed into toroids. But not only that, but they are aligned. They are aligned with the opposite polarity, north-south, north-south, north-south. So to answer your question, on the sufficiently powerful 200 or 300 kilowatt, not little toys, magnetic fields, you create an arc submerged in water, in any liquid that you want, that positively will create a gas with a molecular structure, proved beyond doubt. Come to our laboratory, we'll send you a sample and... Yes, go ahead.
Yes, I just want to make a comment about the how iso superconductivity occurs. It does not occur in vacuum. What happens is, if I'm the proton, and there are two electrons, one to the left, I pull this electron near and this one near, and I sudize the proton away. So they'll appear to attract, but there's always some substructure that enables the attraction, that mediates it. In conventional superconductivity, that's called the phonon. That's the vibration of the atom is converted to phonon. Is that vibration that is Sudized away. This idea of Sudizing something away came from P.W. Anderson when we went to Royal Society meeting in London, and he talked about the new superconductors, how you can Sudize oxygen away. So it's just by way of explaining the mechanism. And the concept of pseudo-potential theory. You know, for example, that in metals, electrons move as if there are no potentials at all. And that's because the high kinetic energy cancels the large negative potential energy. And in other words, the deep potential is Sudized away. So I'm coming in from solid-state physics, and what I regard we're doing is pseudo-potential theory. But the pseudo-potential theory, as Professor Santilli pointed out, is non-unitary. You have to correct the whole formalism, and that gives you hadronic mechanics. Thank you.
Incidentally,
Professor Laviolette.
If I may, just a comment, because Professor Animaleo's work is, sorry. Professor Animaleo's work on superconductivity is really beautiful. It should be recognized. It has not yet been recognized because he is the only one that I know achieves an attractive forces in the Cooper pair. And he achieves this in a way beautiful in what I call Animalo-Santilli the trigger, the effect. He achieves it beautifully because then he used the cuprates as the trigger. But the cuprates are a long-distance interaction is conventional quantum. So the structure of his superconductivity is absolutely magnificent and avoids phonon. I recommend, and it predicts higher temperatures. There is a very powerful prediction for higher temperature. But, so I definitely recommend it.
Rogero, you have already realized that I appreciate your work. Now, to make it clear, I'm from the first hour in high energy physics with Tiering. You know that. So I'm a mathematical physicist, but I became professor in sociology. So I want to answer as a sociologist. I have followed the works of the Santilli group for 10 years, and they belong to the greatest American academic society. This is the American Chemical Society with, I think, 170,000 members. Now, Santilli is basing his theory of the water molecules on proton tunneling, not on valence. And he uses the mathematical instrument of group theory. And I can imagine now, by intuition, as a sociologist, which kind of opposition you have met. And I would beg you, as a friend, because you have very positive attitudes towards friendship, that you do not exert so much power and do not be so strong, as you say, because then you are just reacting to that system which exercises so much violence against you.
That, I agree about the point, but I cannot change I believe that, according to my experience, what you state is very, very true. But let me tell you what I'm not writing for my colleagues. I will never be acknowledged academically, never. So what is, and I'm not after prizes. We'll never get any, sure, for friends. But so what is my aim? My aim is the following. Unless somebody initiates the denunciation of what it boils down, corruption, who will do it? If I don't do it, I'm outside academia, I'm not a member of the American Chemical Society. I terminated my membership. If I don't do it, again, remember my words, if we are silent in front of this clear manipulation, we become either accomplice or servant.
What servant?
This is servant of manipulation of science.
This can happen here too. If you exercise too much power, then also you have a lot of
That is also true. That is also very, very true. But the science has to be now. What you mentioned about the proton exchange, as a valence bond. It's purely theoretical. The reality is that in reality we have a valence bond. There cannot be a proton exchange in between valence bonds. No, it's a manipulation. Sorry for that.
Thank you.
But you're right in stating that they're against me. But I don't care.
My question is...
Sorry, I have to... Another reason why I am violent.
Okay.
I have to be... Let me be open. This is for everybody. The academia is not... Anybody who does not follow basic advances makes a gift of discovery to us. So when they are out, and I'm happy because they make a gift of scientific priority to us. Let them stay out. No, I have no interest in them. We don't need them.